Transformation of trigonometric functions. Consider the function f of x equals to 2 minus 3 sine 2x minus 60 degrees. I would like you to take this as a test and do all these problems on your own. So stop the video now. Once you have written down your answers, then look into my solutions. Question 41. Time period of f of x is 42. Phase shift of f of x is 43. Range of f of x is 44. Maximum of f of x is at, and 45. Value of minimum of f of x is. So answer your questions and then look into my suggestions. Here is my suggestion. Now, whenever you are given a function like this, I have seen students making a lot of mistakes. And a major mistake is that they do not factor out this 2. And that creates a problem in writing phase shift. So first thing is, rewrite this equation in standard form, right? What I'm trying to say is, write this statement as, let me write here itself as, let's write this first. So we have minus 3 sine of, within square brackets, factor out 2, right? 2 times x minus 30 degrees, bracket close, and then you write plus 2. I'm writing plus 2 here, plus 2. So that becomes your transformation equation for this sinusoidal function, okay? Now do you see the change? When you factor out 2, you get x minus 30 degrees, very clearly indicating the phase shift. Otherwise, I've seen many test papers where I see 60 to the right as the answer for phase shift, and that is a wrong answer, right? Now let's answer the questions now. Time period of f of x is, now time period is decided by this k factor, right? If you compare it with standard equation of transformed equation, then this 2 decides the time period. How? The time period t is actually equals to 360 degrees divided by this number, which is 2. So here the time period is 180 degrees. So that is the time period. So basically what you will see in this case is that you have 2 waves, not one, but 2 waves within, like this. Let me just sketch them for you. So we have 2 waves within 0 to 2 pi. Right, so if that is your axis of symmetry, we'll sketch the whole thing as we go along. Then from here, so this is one wave, and the time period is 180, do you see? And the second wave, do you see that? So what we have here is, one wave has a time period of 180 degrees, and there will be 2 waves in 360 degrees. So that 2 indicates number of waves in 360 degrees. So the time period is 360 degrees divided by 2. Now phase shift. Phase shift is 30 degrees to the right. So we can write plus 30 degrees, or we can clearly write 30 degrees to right. Range. Now range is, it has moved 2 units up, right? It has got reflected, and times 3. That means initially our range was from plus and minus 1, right? Now to that plus and minus 1, we have to multiply by minus 3 and add 2 to it. So think like this. So the whole thing has moved to y equals to 2, and now because it is flipped, so it will kind of look like this, but like very enlarged, right? It will be 3 times, I'm not drawing that big, but what I'm trying to say is that it will be kind of like this. Correct? So all the values gets multiplied by 3, and it flips like this. So it becomes 2 minus 3. So this is at minus 1. And here when you add 3, so the peak will be at 5, right? 2 plus 3, 5. So the range basically is from, I should write minus 3 first. Sorry, minus 1. So range is from minus 1. So y is greater than or equals to minus 1 and less than 5. So that is the range for us. Now maximum of fx is at. Now the maximum is at quarter of the cycle. Right? So maximum minimum occurs at quarter of the cycle. Right? So as you can see from here, the maximum actually happens at the original minimum because of minus here. So maximum occurs at 3/4 of the cycle. So maximum is at 3/4. So let me write 3/4 of the time period, and time period is 180 degrees. So that is how you're going to find the location of maximum in this case. So 1/4 of 180 degrees, which is 45, times 3. So it is 3 times 45, right? So it is 135 degrees. So that is the maximum at 135 degrees. So this is your maximum. Do you understand? Value of the minimum of the function is, minimum occurs at 90 degrees here, but they are asking for value, right? The value is minus 1 in this case. So that is how we are going to answer these questions. It's a good idea to kind of make a rough sketch of the graph and then answer the questions, right? Because you might do a mistake in maximum and minimum also. So you have to be very careful when doing transformation of this kind of function. First and foremost, rewrite your equation in standard form. Second, sketch it. And then answer your questions, correct? That way you will ensure correct answers. Thank you and all the best.